going to study Vulkan and go over Godot's source code. Probably not gonna study Vulkan too much, just gonna go over the source code because I've been studying Vulkan. I'm gonna share some of the resources that I found. So there's not many because I haven't, like the resources that I found have a lot of stuff, and Vulkan is a lot more complicated than OpenGL. But so far, I think that Vulkan is a lot better. It seems a lot better than OpenGL is. So it seems like they fixed all the mistakes that OpenGL has, and they allow you much more control over what happens. So I've been liking Vulkan a lot more so far. But the downside is that's a lot more complicated and hard to understand. So that's what I'm trying to figure out more now. So it's easier to understand what's going on Godot's source code because Godot uses Vulkan. It depends on what kind of situation, I think, but for the most part, it's probably going to use Vulkan. So, and for the executable that I'm using now, I think it is using Vulkan. So I want to understand how Godot is selecting the shaders that it uses to create the editor and how it compiles them. And the whole pipeline, how the graphics pipeline is implemented on the Godot source code. So that's what I'm trying to figure out now. I'm gonna wait a little bit to see if it's streaming. Usually it takes longer on YouTube, yeah. So the main one that I found that I think I didn't like the documentation very much. This is, as far as I know, the official documentation. And there is some place here where they incorporate this tutorial as well. And there is the code. I don't remember where I got the code from the tutorial, but I'm sure if you search for it, it's not that hard to find. And I downloaded and put it here, which is just the code that they put here as the within the articles. And yeah, I think it's this one. So I might go over the code now, but I think I'm probably just gonna step over the Godot source code. So this one I think is much better than this one, which is the official one. Then I found this video here from the Vulkan YouTube channel, and they have, on this video, he talks about this GitHub Ripple here. And I haven't looked into all the diagrams so far, but it seems very helpful. So there's a bunch of diagrams that explain the pipeline and how it works. So as far as I understand now, you have the context, the Vulkan context, which is the main thing that you're gonna use to interface with Vulkan. Then you have the physical device, and the physical device is gonna have queues, and each queue accepts commands. So I'm gonna go over the notes that I took there. But basically the way that it works is that you submit a bunch of commands to the queues, and then you have to synchronize the queues in order to do draw calls, and then you use images, and Vulkan allows you to have control over the double buffering technique, which is usually on OpenGL this happens as well. When you're using GFW, you use the swap function at the end of the loop, which is basically you paint everything on one image and you show another image that is complete. And then once you're done painting on one of the images, you swap the two images. So that way it seems that it's more effective. Like it seems that more continuous, the updates. And what Vulkan does is it allows you to put as many images as you want. So it's not only two. So you can view it as a gradient where you can create several different images and update them gradually. But obviously this adds a lot more of complexity. And then you have this system which is called Swapchain that allows you to iterate over the images so that you do the updates more effectively. So you have to connect that with the queues and synchronize the queues. And the best playlist that I found so far is from this guy here. But it is a lot of videos and it takes a lot of time. So I'm probably gonna have to review this again a bunch of times. And I also found another channel, which I'm gonna look there in the images, that have some really helpful diagrams as well to understand what's going on. And basically the way that it works is that it's very similar to OpenGL, but it's like a more complicated version of OpenGL, where instead of using the shaders directly to create the program, in OpenGL, you get the shader code from the file, you read the file, then you pass through an OpenGL function, and then you use that to create the shader code and the shader program. So in Vulkan, what you're doing instead is you have to get the, if I'm not mistaken, is the binaries, the binary representation of the code. No, you get the code the same way as you would on OpenGL, and then you call another program, which is an executable that you use to compile the shader into an intermediate representation, which is SPRV, S-P-R-V, which is a language that they use to run the shader code inside of the driver. So it's just another step. You get the shader code and then compile using this stuff. And then after you compile, you call some OpenGL functions to, not OpenGL, some Vulkan functions to store the information on the, I think it's the context. And basically the way you get the physical device is by, there's a bunch of videos that talk about this. But it's basically this function here. You call a Vulkan function, and then the Vulkan function is gonna return the amount of devices that the computer has that accept Vulkan. Then with that count, you call another Vulkan function that is gonna, depending on what kind of logic you put there, is gonna select what kind of GPU you want to use. So let's say there are two different GPUs on the machine. One is connected to the user interface, to the monitor, and the other one is not. And you want to select the one that is connected to the monitor, so you put the logic, then you call the Vulkan function, and then you're able to select which one you want to use. In OpenGL, you're forced to use whatever they choose, as far as I understand. There's this code here that I wrote here, but there is some stuff on the Vulkan tutorial there that explains. This one is basically the one that gets the device count. So you pass this, and it's going to return. Then you create a vector. This is initializing the vector with this name here and passing the count. So you're creating a vector of the size of how many GPUs the system has, and then you call this other function here, and then pass the devices data. And as far as I understand, this is gonna store the physical devices, which is this struct here, on this vector. And this is the struct that Vulkan uses to keep track of the physical devices. And there's this logic, something that is, I think is the context, then you have the logic, which is just a fancy way to say the structs that Vulkan is going to use to manage the thing, that you use to manage the connection with the context and the physical device, I think. A lot of the stuff is still confusing because I'm learning, obviously. So, and the other confusing part is this descriptor. So I wrote down some stuff here. I think I'm just gonna go over these notes that I took here. Then maybe, let me see if I'm gonna watch these videos again for sure. I think I talked. So this is pretty much all the resources that I got so far. Probably gonna go over some of this, but I think I'm gonna go over them later after I go over the Godot code, or maybe another day, because I want to have a more clear understanding of how it works in practice on Godot, because I already know based on the tutorial. I already read this tutorial. I'm reading it again to understand more how it works. The hardest part to understand is definitely the synchronization, and this is the best video I found so far. You have this semaphore and fences. It basically works in the same way that the logic of a traffic would work. So you are responsible for setting up the traffic, let's say. So set up the semaphore and fences to synchronize the queues so that you can kind of, it's the same logic as multi-threading programming. Use multiple different threads to optimize the speed in which you're going to do things. But then it becomes a lot more complicated because there's a lot more room for mistake. So yeah, let me go over the notes. Then I'll go over the, I already found on Godot. So before I go over the notes, I found that the functions that are responsible for compiling, as far as in the sun now, because I just looked into the stuff that Vulkan uses on the whole process there, and then I just searched on the project, and these are the main functions that are responsible on the Vulkan driver to compile the shader at the beginning. So I'm trying to figure out, I'm going to step over the Godot code to see if I can figure out the points at which it's going to select what kind of shaders it's going to use on the editor. That's the main thing that I'm trying to figure out now. The Swapchain, Vulkan allows control of the double buffer swap, which is used to paint the image first while presenting the other image and then swap them. So there's stuff that I explained about iterating over the images, blah, blah, blah. And there's the minimum amount if you don't put, so they allow you to select the minimum amount of images you want. But if you don't put anything, I think the minimum is true. But I don't remember really well. In order to determine what happens on the back buffer, semaphore and signals are used, which is the stuff about synchronization that I talked about. Because you have to move. So the difference, as far as I understand now, between OpenGL is that OpenGL, you put a bunch of commands, and then depending on the order you put them, it's going to draw stuff. So for example, you set up the buffers, use GL attribute vertex, and GL buffer data. And then you do the draw call, which is GL draw arrays or GL draw elements inside of the rendering cycle. But on Vulkan, you create the commands, and then you put the commands on queues. And then each physical device has queue families. So it's like you're structuring multiple different lanes. Each lane is a queue. And then you put whatever commands you want on those lanes. And then these lanes use descriptors, which is kind of the information that is going to allow you to specify what happens with each command, which is similar to the way GL attribute vertex work, where GL attribute vertex allow you to specify how OpenGL is going to read the buffers. The descriptors are the things that allow you to specify how OpenGL is going to read the commands, as far as I understand. And then you have semaphore and fences in order to synchronize the multiple different queues you're using to create this pipeline, where you're drawing stuff on the image in a multi-threaded kind of way. The FIFO mode Swapchain, the images are partially replaced in the image displayed as they load in the background. The GPU selected randomly, but on Vulkan you are responsible. VK device is the logical device. Yeah, this is the name I was thinking about. But I don't remember really well what kind of parts it goes. I think it goes, it is the abstraction that allows you to manage multiple devices, I think. Use the logical device, which is connected to the context, I think. But I don't remember really well. Which is the interface between your program and physical device. Yeah. Also, it's one step after physical device, probably. Emulate the physical devices so you can select them from basically. I think it is the way that I was saying. So logical device manages physical devices, probably. So we have one logical device per application, and then each logical device manages multiple physical devices and the state of each physical device. I'm gonna have to review, obviously. The queue always belongs to the queue family. VK descriptor allows you to specify different values that are used on the shaders. These are the kinds of descriptors. There's a bunch of them, but these are the ones that I wrote. Read only can only be loaded, but not everything. So descriptors, as far as I understand, is very similar to the specifications you give to OpenGL on how to read the buffers you set up. It's kind of like the same logic, but slightly different because Vulkan is more complex. I think this is one of the things that so far I haven't wrote anything, so I don't know how annoying it is. I'm sure that is difficult when you're writing because it's more complex. But as far for now, I think that's I like much more because everything is on structs. So it seems like it's just it's a better way to manage everything and it allows you to have a lot more control. So I'm liking it a lot more than OpenGL. I think it's a lot better, but it's harder to learn at first. Use if you want an image view different than texture. Image means the whole thing that will be displayed. This thing I wrote down, but I'm not 100%. I don't have 100% confidence that this is the case, but I think it is. So when they talk about image, they are not talking about texture. It's different. The image is the final thing that they're gonna display, and there's some other stuff related to textures. But textures, I think that is different than OpenGL, where OpenGL have different functions to set up the buffer for textures, and then on Vulkan, if I remember correctly, you use the same logic, which is you use the same command buffer, but you store the data in a different way, and then you do the descriptors in a different way, as far as I remember. Descriptors are in the bounds of command buffers, and they're always organized in descriptor sets. Bounds to command buffers. So it's descriptors, then command buffers, and then the queues accept command buffers. and you synchronize the queues to do the cycle of drawing. Scriptors are similar to GL attributes vertex from OpenGL. They allow you to specify how the buffers are going to be structured. Vulkan's exact version of GL attribute vertex is VK vertex input binding description and VK vertex input attribute description. Commands are the specifications of what should do with the descriptor that were sent before. VK command draw, for example, is related to making draw calls on the GraphX pipeline. I'm pretty sure that on Godots, the class that is responsible for this is the driver. And there is the rendering driver, which is the base abstract class, and then the derived class are rendering driver Vulkan and rendering driver D3, D12, or something like that. And this is one example from one of those resources that I shared before. I have command pool. So this is the flow of the commands based on the functions that it calls there. Oh, there's another thing that I have to allocate memory, but this I didn't pay too much attention so far on the nuances of allocating memory, because I'm more curious about the shader for now. So this is the first question that I had, which is the device thing, and this is the answer. Just get the counts and then it pass, like I explained before. And this is the example of how they in Godots is more complicated. There's more stuff, but it's pretty much the same structure, where you use in Vulkan they use a module, as far as I know now, and then they have the source code of the module, but then they just call the functions from the module, external module, that's gonna compile, which is the same program I think that they're using here, which is this glslc executable. So you get the shader from the normal extension, you just write the shader, then you use this executable to compile into this intermediate representation, which is the way that the Vulkan is going to understand. And then from that, you read the file, get binaries, and save on this variable from the intermediate representation file. And then you call this function here, passing the binary, and you're going to save on this struct here the results of the compilation. So I got the size and the data reinterpreted to uint32 instead of this structure. So I think that's pretty much it. So I'm gonna go over Godot's source code. This is one of the main functions. The three main functions that I found, I think I already talked about, are these three here. So I searched in the project and I put some breakpoints there. I'm just gonna press F5. The most annoying thing is gonna be that there's a bunch of breakpoints. I'm probably gonna have to remove a bunch of them and just leave for the stuff that I'm interested on now. And I'm gonna press F5 on everything and see if I can find the functions. If I get stuck on some loop or something, then I think I'm just gonna remove the breakpoints. Main thing I'm trying to figure out is I also have, oh, I forgot the images. So I took some images from another channel that are very good. This guy here, Alejandro Salcedo, if I'm saying this correctly, is very good, the video from his channel. And these are the images of how the thing works. And so this makes it easier to see. So the logical device is after the physical device. So it's thinking about backwards. It's a very good video, so highly recommend. So the main thing that I'm trying to understand is, so there is all these files here from Godot's. I got this from Godot's documentation, and I don't remember really well exactly which shaders. I guess there's a name here, so I can see maybe this shade. Yeah, but I don't think they. Maybe they talk about it, but I don't remember what kind of shaders are used to build the editor. So I'm trying to understand how the editor is built, so I can change the codes. And I want to understand, clarify what kind of shaders are used to build the editor, so I can see how the camera is gonna, how the shader is gonna be updated with the value of the camera, and how are the geometries being created. I think that's the main thing there. So I'm able to draw stuff directly on the viewport without using the editor. So I assume that at some point there's gonna be this thing here. I don't remember if I looked into the, if I searched this on the file there on VS Codes directly. So maybe that's an easier way to figure out. But even if I do find the functions that call this path here to read the file and compile, I still have to understand the flow, I think, of how it works. Then once I clarify what kind of shaders they use exactly to build the GUI elements and the view part in the geometry, then I can look at the shader code and understand how to compile and interact with the codes after the initialization on the engine. So when I press 5, hopefully I don't miss anything. I'm not sure if it's gonna stop. The thing that's kind of hard is that even if you stop, so the way that I'm thinking about doing is pressing F5 until I get to some of the breakpoints that I put there that are related to the shader, and then I just try to step out of it, whatever function it is, to see what place the function is called. I think I can, but like, if I search directly, I don't think I found anything, which is kind of weird because I should find the place that calls the function and then follow backwards the path of execution, but I don't think I found. Probably missed the function that is used as the entry point to search for. So I guess there's another option that I can do, just search for the name here on the files, name of the functions that I got there, and then just go over all of this. I'm pretty sure I put breakpoints on all of them. Because if the function is called, then obviously it should be written somewhere else, so you should look for places where the function is called and then walk backwards, figure out. This one is the one that I stopped last time, so maybe I stop into this one. So this is probably the first. This, I think that they are signing up the function on the class, if I remember correctly. And this function is from the external module. So this is going to be, the function is the equivalent of the external library there. This. So I think it's the equivalent of this one from the tutorial.